I know trigonometry can feel a little scary, especially when you're learning a new unit of measure called radians. If you're not sure how to use it, it's okay. I will teach you all about it, everything you need to know, and how to make you feel comfortable using it with trigonometry. I understand learning trigonometry can seem a little scary, but this is something I want to help you with, and I can help you understand. Today we're going to learn trigonometry in terms of the unit called radians. If you have not checked out my video with trigonometry in terms of degrees, make sure you go and do that as well. But let's get started today in talking about radians. So if you don't know the first answer to the question, I just answered it for you. The unit of measure that we're going to talk about today is called radians. And we're going to learn about radians in terms of degrees to help make it easier for you to understand. So the first thing is, how do we normally find the circumference of a circle? Hopefully you remember that the circumference of a circle equals 2 pi r. And what does that r stand for? That r stands for your radius. So we know the circumference of a circle, and now how many degrees are in the circumference of a circle? Hopefully you remember that's 360 degrees. So these are both two pieces of information that you've known in the past that we're going to use to help you explain radians. Since we both know that those reference the circumference of a circle, we can set them equal to each other, and we're going to make sure the radius that we're going to use is 1. So we know that 2 pi r is the circumference of a circle, and circle circumference equals 360 degrees. And we're going to let r be 1, which means that's going to drop out. So 2 pi equals 360 degrees. You with me so far? Okay, good. Therefore, we now know that a full circle is 360 degrees, and it also equals 2 pi. And that is our radian measure for a circle. Therefore, we now know that the radian measure for a circle is 2 pi radians, which is the same as 360 degrees. Now let's label our circle in radians. We start again here at 0. We are moving counterclockwise, and we just learned that the full circle in radians is 2 pi. Right? Because that's where our 360 degrees mark is when we're working with degrees. So now, what's half of 0 and 2 pi? Well, if you have 2 pi and you want half of that, just 1 pi, right? So over here at the half circle, this is just your pi position. That's pi radians over there. And I know sometimes it's weird to think about pi. If you think of it a little bit like a variable, and you just think what's 2x and what's half of 2x, it's 1x. Okay, so we're going to kind of use pi as a variable in a sense to help us label this. So in the top half of our circle, you have 0 to 1 pi. Well, what's half of 0 and 1? That's right, a half. So up here at the top is just half pi. And they write that with the pi in the numerator and the half part, or the 2 for the half part, in the denominator. So pi over 2 is how they call that fraction up here. So then at the bottom half, you have pi, 1 pi, and 2 pi. Okay, so now think, what is the middle between 1 and 2? Well, it would be 1.5, right? What's 1.5 as a fraction? Do you remember? Yep, so 1.5 as a fraction is 3 halves. And what they do is they put the pi up here in the numerator with the 3. So the way you say that is 3 pi over 2. And so now you have just labeled your unit circle with trigonometry in radians. And then you can compare that to how you do it with degrees, right? So with degrees, this would be 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So now you have a trigonometry unit circle labeled in both degrees and radians. This is something you definitely want to keep in your notes to keep handy because these are points on the circle that you will use quite often. Using degrees is probably usually a little easier because it's a unit of measure that we're most familiar with. But we need to know how to convert from degrees to radians and radians to degrees to be able to solve some other problems. So that's what we're going to look at now. The circumference of a circle in degrees and the circumference of a circle in radians, which we already discussed in the previous page. So this is 360 degrees equals 2 pi. Right? That's the end, that's the full circle for both of those. So now we're going to simplify down to pi. Well, to simplify down to pi, we're going to divide by 2. 180 degrees equals pi, which should make sense to you because we just labeled that on the other page in the unit circle. Now we want to figure out what is 1 degree in radians so we can do any kind of conversions that we want. Well, if we have 180 degrees equals pi, and we want to get rid of the degrees and we want to make this a 1, you have to divide it by its same number. What happens here is that the 180 becomes a 1. So we're left with 1 degree equals pi over 180. So this will be our conversion that we will use when we're trying to find out a certain degree in radians. So let's try this example. What's 90 degrees in radians? The way you're going to do this is 90 degrees. We want 1 degree. We're going to multiply by pi over 180 degrees. And that's how our degrees will cancel out and we will get our answers in radians. Well, guess what? Now you can simplify. 90 goes into 90 once, 90 goes into 182, so you're left with pi over 2. Which hopefully, again, you should remember from the unit circle that we did, that at the top was 90 degrees. It also equaled pi over 2. All right, let's try 30 degrees. So 30 degrees over 1 times pi over 180 degrees. 30 goes into 30 once, 30 goes into 186. So pi over 6 is the same as 30 degrees. And that's something we'll get into more in my next video, so make sure you check that out too. Okay, let's try a couple more. 45 degrees over 1 times pi over 180 degrees. 45 goes into 45 once. 45 goes into 180, 4. So pi over 4 would be your 45 degrees. Now let's try 60 degrees. 60 degrees over 1 times pi over 180. 60 goes into 60 once, 60 goes into 183, so pi over 3 is 60 degrees. And you can do these with any problems. They might not simplify down as much as these, and that's okay. But it is good practice to be able to convert degrees to radians. Let's try one more. 270 degrees over 1 times pi over 180 degrees. Now this is the first time we've had a bigger number in the numerator. So let's think about this. 9 goes into both 27 and 18. So 90 would go into 270 3 times, and 90 would go into 180 twice. So notice now we're left in the numerator with 3 pi over 2. Which again, hopefully you remember on that unit circle that we did, that 270 degrees at the bottom was 3 pi over 2. Okay, now let's say you have radians and you have to get back to degrees. How are you going to figure that out? So again, we're going to start with our 360 equals 2 pi because we know that from our unit circle. And now we're going to simplify down to pi. So now I'm going to get rid of the 2. So now we have 180 degrees equals pi. And I want to get my radians all by itself. So I need to divide both sides by pi. And when I do that, right, because we're trying to get rid of the radians, I'm left with pi over 5 becomes 1, and this becomes 180 over pi. So notice this conversion when we're going from radians to degrees, that fraction is flipped because of the unit we're trying to get rid of. So let's do a couple of examples real quick. So now we have pi over 9, and to get that into degrees, we're going to multiply by 180 degrees over pi. So our pi's cancel out. 9 goes into 9 once. 9 goes into 180 20 times. So our answer is 20 degrees. Let's try the one on the right. Again, to get down to degrees, we're going to multiply by 180 degrees over pi. Our pi's will cancel, and 3 goes into 3 once. 3 goes into 180 60 times. So 2 times 60 is 120 degrees. So 120 degrees is the same as 2 pi over 3 in radians. Okay, let's try this next one. You want to get down to degrees, so you multiply by 180 degrees over pi. Your pi's will cancel out. Now let's see if there's anything else we can cancel out. Both 4 and 180 both have a factor of 2. So 2 goes into 4 2 times. 2 goes into 180 90 times. So in the numerator, we have 5 times 9, well 90, so 450 degrees, over 2. Now we just divide. 2 goes into 4 twice. 2 goes into 50 25 times. So 225 degrees is 5 pi over 4. Okay, last one. Are you ready? So let's try multiply by 180 degrees over pi. Our pi's cancel. Oh, good. 6 goes into 6 once. 6 goes into 180 30 times. So 11 times 30, 330 degrees. The next part that you need to understand in how to deal with radians is when we're dealing with the complement and the supplement of an angle. So again, the complement and the supplement, it's when you're adding up 2 angles. So the complement is when you add 2 angles, and when we were talking in degrees, it was when they added up to 90 degrees. So what's 90 degrees in radians again? Do you remember? That's right, it's pi over 2. So they need to add up to pi over 2. But when you're doing the supplement of 2 angles, they need to add up to pi. So again, notice they must be in radians in these problems. So anytime you're dealing with pi, that's going to be your radians unit of measure. So let's try a couple of examples of how this will work. So let's find the complement. Okay, if we're going to do the complement first, that is pi over 2. So I need to know what plus pi over 4 will give me pi over 2. Well, if you think about it, just think about this as 1/4. What do you need to add to 1/4 to get to 1/2? Well, another 4th. So the complement of pi over 4 is another pi over 4, right? Now let's talk about the supplement. If we want to do the supplement part needs to add up to pi. So think of pi as one whole. Right? If we have 1/4 of the pi, how many more fourths do we need to make that a full pi? You've got 1/4, you need 3/4 more. So the supplement would be 3 pi over 4, and that's how you would make a full pi. Let's try it with pi over 6. Again, for the supplement, they need to add up to pi over 2. So for this one, you may want to remember how to subtract fractions, or you can think about it mentally, whatever works best for you. I'm going to show you 2 different ways. You could do pi over 2 minus pi over 6, right, and get common denominators. But what do we remember about pi over 2? If we turn this into a fraction, to simplify down, this would need to be 3 pi over 6. So if this is 3 pi over 6, 3 pi minus 1 pi is 2 pi over 6. But of course we must reduce to pi over 3. And this would be your complement for that angle. Now your supplement part for that angle, again, it's got to equal a full pi. A full pi is going to be 6 pi over 6 minus pi over 6, which gives you 5 pi over 6. So this part would be your supplement for that angle. Now there might be some angles that are greater than pi over 2. So there's not going to be a complement for them, and there's only going to be a supplement for them. So again, for the supplement, we need to find out how they add up to pi. So 2 pi over 3. If you have 2 pi over 3, a full pi would be 3 pi over 3 minus 2 pi over 3. So 2 minus 3, you've got pi over 3 for the supplement of this one. On the second problem, to get a full pi, you would need 8 pi over 8 minus 7 pi over 8. That leaves you with pi over 8. So a lot of times you're just dealing with basic fractions. Hopefully you remember how to do those. And if not, you can turn them into common denominators. Remember, anytime you're dealing with pi, you want that same number over itself so it cancels out to make a 1. And that's how you can easily subtract to find your supplement. I know learning trigonometry can be a little tricky, but you can definitely do it. Learning a new unit like radians takes a little bit of getting used to, so make sure you have those conversions handy in your notes so you can grab them at any time that you need to do these. Be sure to check out my other videos on degrees and labeling the unit circles and on the trig functions themselves to help you master trigonometry. Also, be sure to share this video with another friend who might be struggling in trigonometry, so hopefully they can understand a little bit better as well.